This is a general continuous random variable sum. So we have a CDF given. We have to find the median. The formula is CDF equals to 0.5. So fx equals to 0.5. Therefore 4 by 9 x squared plus 2x minus 3 equals to 0.5. Let's solve this equation. So this is equals to 0.5, and we solved a quadratic equation because it was given that the median has to be 3 significant figures. So we have two values. How do you choose the median? So you can see here that the limit is from 1 to 1.5, so it has to be between 1 to 1.5. That's why this is the median. The next question, find the PDF. You know the formula for PDF is we have to integrate. For finding the PDF, for finding the CDF, we need to integrate the PDF, and for finding the PDF, we need to differentiate. We need to break it down. D by dx of fx. So this is going to be d by dx of 4 by 9 x squared plus 2x minus 3. Now you can just keep the constant outside, it's alright. Just differentiate whatever is inside. So this is 2x plus 2. So you can take the 2 common and it would be 8 by 9 x plus 1. Now this is not done. You have to define the PDF. To define the PDF, you need an expression here which is 8 by 9 x plus 1, comma, the limit is the same as the CDF, x to 1.5, and you need to write here 0 otherwise. Question number C, find the probability. So find the probability of x is greater than or equals to 1.2. Remember, if you have the CDF, you can find the probability if it is less than. So since this is continuous, it is the same as less than 1.2. It makes no difference. In continuous, it makes no difference. So 1 minus f 1.2. So now we can just put the value and find it. So the CDF expression is 1 minus 4 by 9 1.2 square plus 2 into 1.2 minus 3. So this is going to be 0.3733, so that makes it 0.6267. The next question is, a camping lantern runs on 4 batteries. So first information is 4 batteries, all of which must be working. 4 new batteries are put into the lantern. Find the probability that the lantern will still be working after 1.2 hour. Now if you see this and this matches. The previous sum and this sum matches. So this is an irregular sum, and this sum can be given at the end of any sum. It's a binomial distribution that needs to be made. So the probability of success is after 12 hours. So P equals to 0.6267. N is 4. So this is that the battery is working. So we can use the alphabet. Y, number of batteries working. So now they have given another number here. 4 batteries are working. So this is the n and this is the random variable. So therefore probability of y equals to 4. So for doing this particular sum we have to use the PDF, because this is not in the table but it is within the limit of the table, but this is also within the limit of the table, so we have to use the PDF. We cannot use approximation here, and in approximation it will be mentioned use the approximation. So therefore this is equals to NCR 1 minus P to the power R, this is 0.6267 P to the power this, and this is equals to 0.154. A company has a large number of regular users logging onto its website on average. So that means on average means this is Poisson. Every hour 4 users every hour fail to connect to the company's website at their first attempt. Okay, Question number A. Explain why the Poisson distribution may be suitable model in this. That means properties of the Poisson distribution. So events, it has to be in context. Customers or users, they use the word users. Users fail to connect singly, independently, and at a constant rate. Question number B. Find the probability that in a randomly chosen 2-hour period, so the first information was every hour, so this is for 2-hour period. So let's start with 2 hour. So number of failures, meaning failure to connect, or number of users failing to connect per 2 hour. So I'm starting directly with 2 hour Poisson. So every hour is 4 user, 2 hour means 8 user. So therefore probability, this is B1, numbering is very important. All the users connect. So how many fail? None. Okay, so this means probability of X is less than or equals to 0. That means 0.0003. Question number B2. At least 4 fail to connect. So at least 4 fail to connect, that means more than 4 people or equal to 4 people fail to connect. That means 1 minus probability of X is less than or equals to 3, 1 minus 0.0424 from the table. If you have to look up the table where lambda is 8, then if you subtract 0.9576. Now the next question, question number C. The company suffered from a virus infecting its computer system. During this infection, it was found that the number of users failing to connect to their first attempt over a 12-hour. Now notice this, 8 hour, 2 hour, now it is 12 hours. So the random variable is going to change. And 60, what does this 60 mean? The number of users failing to connect. So 60 people fail to connect. So this is the random variable, number of users failing to connect. They have given this to information. Okay, let's read the question now. Using a suitable approximation, test whether or not the mean number of users per hour who fail to connect at their first attempt has increased. So hypothesis testing, H0 lambda equals to the original information 4. Always read the first line for H0, and increase means lambda is greater than 4. So this is the first hypothesis testing, always based on the first line. Now we have to find the probability. To test this we need the distribution. So distribution is for 12 hours. So Y, number of users failing to connect per 12 hour. That means the distribution is, if it's every hour is 4, so 12 hour means 4 12s are 48, and the random variable is 60 people failing to connect. So that means matching with H1, probability of Y is greater than or equal to 60. Obviously we have to use the distribution because this Poisson distribution cannot be used because the value of lambda in the table is up to 10. So using normal approximation, so we know mu equals to lambda, which is 48, and sigma square is also equals to lambda. So the distribution is, let me use the random variable a, so mu comma sigma squared.